This is a continuation of a debate I've been having with DraftPhysics about the nature of light and space. So this is part two, and in this we'll be discussing some of the questions that Gary has asked about how an ether is supposed to work. I would like to congratulate Gary for keeping this discussion very scientific, and so he asked a number of valid questions, and I'm here to give him some answers. So this is our topic. How does, say, my ether work? I don't know about other people's ether, but so Gary first asked, what is the format of the ether? And yes, you should be able to draw a picture. Okay, now the picture that Gary has got here, is one, I don't know, possibility that, that's like a Lego brick world, and there's a specific like grid. Now, I actually don't think it works that way. There are some instances where it's helpful to think of it that way, but the actual format of my ether is like the molecules in air. Okay, so that's my model of the ether. My ether is made out of positron electron dipoles. So that's the fundamental particle, and it is composed of particles which we do recognize as existing. Except I know Gary doesn't want to recognize the existence of a positron, but I think the rest of the mainstream world, there's lots of adequate evidence to suggest that the positron has the same mass as the electron and has the opposite charge versus a proton, which is like nearly 2,000 times more massive as an electron. So that couldn't possibly be the same thing. So we have positrons and electrons. Okay. Now, the thing is that these are normally considered to annihilate each other, and these things can't exist. So what this really is, for those people who want to relate this to something that we know exists, these are what we currently know as neutrons. Okay. So these particles, but they are still a positron-electron combination. And if you want to read why they don't annihilate, you can read my other papers on what E equals mc squared actually means. But I assure you they do not annihilate. They form a tight dipole, which is almost completely neutral. But we know that neutrons do have a dipole moment, which proves that they do have separate opposite charges involved. They're very, very small. Okay, so my space is, you go like a gas and you fill space randomly, but very tightly. I mean, it's so tightly that there's really hardly any room for these guys to move around. I mean, they're not like gas molecules where they can move like great distances without bumping into anything. It's like these guys are backed about as close as you can get them, right? It's like a billiard table that's completely filled almost with billiard, as if you just dumped in a truckload of billiard balls into it and filled the thing up. So they're virtually touching, right? Okay, but like a gas, they still have some leeway. There's depending on the ambient conditions, these guys will get into a equilibrium condition. So it's not quite like the X as shown in Gary. So let's go ahead in the video here and answer some more of the questions he's got.
Well, what kind of matter? I mean, how to even imagine it. I mean, what you're doing to the atom is...
Okay, so he's asking, what exactly is the atom and what happens when it goes through the matter. So he's about to draw, I think, a fairly accurate picture, which is that he draws the atom and then it's, surrounded by all of this other stuff, right? Okay. And so how do you tell the difference between atom and the rest of these guys? Okay. Now, the rest of these guys, they are neutrons. and they are tightly bound. And what an atom is that we have these things called protons, and those consist of two positrons and one electron. So that is the actual composition of the proton. So you'd see that as, a little collection of like three things, I guess. Okay, something like that. Okay, and that is different from the neutrons, which are a collection of like only two things. Okay, so you can tell the difference between the proton and the neutrons. And then the electrons, of course, are just one little, the electron is just, it's one thing, right? And so this whole thing together would be, say, a hydrogen atom, okay? And indeed, all of these atoms are surrounded by all of these, neutron, electron, positron, dipoles on all sides, okay? So that's how you tell where the atom is compared to the ether. Now, he does ask the question about, what happens when the atom moves. Well, because these guys are so tightly packed together, tighter than what I'm showing here, that in order for this atom to move, it actually has to kick one of these dipoles. Like if it was like here and here, we'd have to kick these dipoles apart, right? And because there is a slight attraction between the dipoles, because they are opposite charges. If they get close enough, they can see the actual opposite charges. And there is a slight attraction. And so Gary says that, I think correctly, is that, he observes that, it takes energy to push the atom. And why is that? Because it takes energy to push this other junk out of the way, right? So part of the evidence for an existence of the ether is that, if I get behind like a Volkswagen Beetle and I push it, even if it was on a frictionless surface, it takes a lot of energy to get it moving. And why is that? Because it has to shove aside all this other matter that's in the way. Because if there was no ether, then if I applied a force to my frictionless car, then it should just immediately take off at near infinite speed. Because there shouldn't be anything in the way, right? It's like there's nothing in the way. It should just, I should be able to just tap it and it should just go zooming off at, I don't know, like 100 miles an hour, because there's nothing to stop it, right? But no, it doesn't do that. It takes energy to get it going, right? So that is how matter would travel through this, I would say, like gaseous. So gaseous, but it's so dense, it's maybe closer to liquid kind of arrangement for an ether, okay? So let's move on. Okay, so his next point is, so I will concede that, if the ether was restricted to a very, very, Lego brick plate kind of scenario, that, it would have to kind of, go that way kind of thing. It's like, okay, I'll concede that. That's why I don't particularly like to use that kind of grid idea. I don't think it's true. What I do think is true is that, all these little guys are so packed close together that, and they're kind of random and they are kind of moving around, right? Like a gas. They may have some Brownian motion to them, that whenever any force impacts one of these particles, that there is always another particle in position to exactly absorb that energy and then exactly pass it to the next closest ether particle. So you can think of it like a Newton's cradle, right? Where Newton's cradle is just like five balls, stuck right next to each other. And you put the energy in one side, and then, boom, it kicks the other ball at the end out, right? Just because it's just kind of like a straight line. And the density of this ether is so dense that there is practically always some kind of straight line that's available in the ether. Although, I would have to say that's a little bit of a stretch, right? But I think it's not a terribly unrealistic thing that has to be believed. I mean, there are a couple things you have to believe, and that, for example, that this is a frictionless process, and that exactly that if you have energy coming in at a particular angle, that there is enough of these ether particles just randomly scattered about to accept the energy and keep it going, and for it to not disperse in various different directions. All right. So let's go on and see the next point here. All right, let's see. That's that point. Now we do get into this thing about, the whole vortex cannon thing. And it's like, yeah, I would concede that the photon doesn't move that way. No. The only reason why I brought that up is to just motivate the idea that that particulate mediums can have non-dispersive phenomena, right? Once again, in order for something to not be magic, you have to be able to demonstrate it in actual experiments. So if someone says that, it has to disperse like this, I'll say, no, it doesn't have to disperse like that. We have examples of phenomenon which apparently do not disperse. So you can't say that that is going to happen, or you can't say that me saying that this goes there is, for example, an act of magic, because, I have corroborating experiments that say that it does. But once again, it's not a very good piece of evidence, because I don't even think it works that way, okay? Once again, I would say that the photon moves as a packet, similar to, I once again use a pen as kind of an analogy, but this might be a grossly wrong analogy, because it just might be that light is generated in, say, single pulses. I think it's easier if you think that light gets generated as a wave packet, has like maybe 4 or 5 waves in it. But, and I've been debating this myself, but ultimately I think it might just be like the representing like one wave inside of something that looks like a toilet paper tube, right? Just short little thing. It's got one blip in it. Is what it is. Just it's like it's got rubber membrane in it, and it's stretched to some degree, right? So to answer your question, is that it's an actual back and forth of the ether particles. The ether particle never has to move from location A to location B. The only thing that's moving is the wave action, compression, rarefication. That's the only thing that is moving there. So once again, I kind of regret having to bring up the vortex cannon example, but that is to provide a counterexample for people who say that all physical mechanisms in particulate mediums like this have to be dispersive, because it really isn't. But photons are a very special case, and they do have a special place in the universe, living inside the very special frame of the ether, which is, like I said, it is a frictionless superfluid. And we don't have very good analogies for frictionless superfluids except for helium. And you can see some of the mysterious properties even there. So that's, once again, an experimental basis. Now, Gary does bring up the point, what is the point of having all this, crap flying around in here, okay? Now, this gets back to my point of magic. Now, I believe I did explain, we have Gary's 2 plus 2 plus 2 physics, which I explained, is actually correct in some ways. But it's complete magic because we don't know where these come from, right? So we can make the reason why we need to put all this crap everywhere is so that this doesn't become magic, right? So it's like, what are the two kinds of matter? The two kinds of matter are positrons and electrons. You see, that's not magic. We know scientifically that those two exist. So I'm not making up any particles. And we know that the neutron exists. So we're not making up anything, really. I mean, even if you don't believe that, you do have to believe that they're neutrons, right? So we are not making up any stuff, okay? And then we have to have two kinds of interaction and two kinds of forces. Now the thing is that in order to generate forces, you actually have to have particles actually crash into each other. So we've got this positron electron. If it goes and more of these things hit this atom on this side, it's gonna push it this way, right? So that's a force. That's just plain Newtonian physics, right? Not magic. We know how Newtonian physics work. We know how things happen when they collide into each other. So the trick is to make it so that we have waves of these things, and then we have waves of these things crashing into the particle, and these waves are bigger on this side than on this side, that we get movement, right? So this is how we get the two different forces that Gary talks about, right? So but actually it's really only one, and it's just a pushing force, as Gary and we both agree there's only a pushing force, right? So we only shoot particles to move them, right? If you ever see two particles moving together, it's because there's another particle over here that's being shoved this way, right? There's nothing in Newtonian physics that creates an actual traction, right? But there you will get different forces which will be coming at different angles. I guess it'd be two-way. And then we have the two interactions. Now, in my case, those two interactions happen because of what electrons do. What electrons do compared to my pen will work. Compared to what positrons do. Okay, these both emit waves, right? And they do it like ring. The analogy is like ringing like a bell. You hit the electron, it rings at a resonant frequency. Okay. So we get that frequency. Then we have the resonant frequency coming out of the positrons, and those are actually always at the opposite phase. Okay. Now what happens is that when the particles come together from opposite phases, those cancel, right? If you have one wave coming in this way, and then you have the other wave coming in the opposite way, the result is like noise canceling headphones. You get them canceled, and so what happens is that between the electron and the proton, those waves get canceled. So there are actually fewer collisions between these guys. Now, at all times, we have the collisions happening on the outside. So these become stronger. So all the particles hitting the positron on this side and all the particles hitting the electron on this side, they become stronger. And that is what pushes the electron and the proton together, without using, say, magic, right? So this is what the importance of magic, that we're only using Newtonian physics. Now, I admit there is still some magic in here, in that you do have to believe some things, like these electrons, every single positron, every single electron in the universe have to be ringing at exactly the same frequency, exactly the same time. And that the smallest possible wave in the universe are the waves which are coming out of here, so that you can never have a partial either in phase or out of phase, right? So some people said, oh, well, it could be off by a quarter wave. Then what's that? So I'm saying that's impossible, because so that is a bit of magic. But my corroborating experiment is like in analogy to what we have happening in digital computers, right? In digital computers, the signal can either be a 1 or 0. It can't be anything else other than a 1, full 1 or full 0. And the state can only change at the same time everywhere in the CPU at the fixed clock rate. So that's exactly a system which exactly follows what I am proposing here, right? So it's not a magical thing if computers are already doing it, right? But it is something you would have to expect. So as a motivating factor, why is it we need all this crap? It's to provide the actual non-magical, Newtonian, fully mechanical explanation for how the two kinds of particles, positrons and electrons, and the two kinds of interactions, which is going to be either an addition or a full cancellation. Those are the two interactions that we get that allow these forces to arise. Okay, I think that's it, but let's go check the rest of the video and make sure we didn't miss anything. I don't think we did. So, and I think that was the important factors that we wanted to consider. Okay, so that will do it for this video. Once again, I'm looking forward to a response on this. I'm still waiting for a response on my magic video. I know he probably, I'm sure he had some kind of snappy response to this, but this is kind of a continuation that I'm showing that, we need the ether to get rid of the magic. Okay. We need to, stop pulling rabbits out of hats. Red force bits don't turn into green force bits. It's just that we have waves and they are interacting, and that is why they get physically pushed around like billiard balls, right? And that's what I mean by a fully mechanical explanation. Theoretically, if I worked on this hard enough, I could get this to work on a billiard table, all right? Some difficulty, right, folks? But that's it, and thank you for your time.